Hi everyone, today we will learn about boost converter. Boost converter means it is step up converter. So here we know step up means your output voltage V out will be greater than V input voltage. So boost converter, it is a DC to DC converter. Input is DC and output is also DC. So input variable DC and output is fixed DC and output voltage is greater than input voltage. So we are constructing this boost converter with inductor, switch that is MOSFET, diode, capacitor and load RL is connected. So this we will see what will happen when a switch is closed. So switch can be MOSFET. So when switch is in the closed position, that is switch is on, how the current flow will be. So when the switch is in the closed position, the inductor will be charging. Here it will be positive polarity and this end will be negative polarity. And the current will be flowing from this supply positive inductor switch to VD minus. Same time, your diode will be reverse biased because anode is here, here negative is coming. So diode is reverse biased, so it is open circuit. And the voltage across inductor will be equal to, that is VL. During magnetizing time is equal to VL. That is same as input voltage. So VL is equal to V in, V input voltage. And next we will see what will happen when the switch is in open position. So when the switch is in open position, the inductor will change its polarity. Before it was plus minus and now it will be changing the polarity to minus plus. So here positive is coming to anode of diode and the diode will get forward biased and here the inductor will act like a source. The inductor will act like a source. So the current flow will be from source positive to source negative. That is from inductor positive, diode through capacitor and through load towards supply to inductor minus. That is L positive, diode towards RL, towards supply positive and supply negative to L minus. And the voltage across inductor, that is voltage across inductor, VL will be equal to, so we know here the voltage is V out. We are considering this as an ideal diode. So this is V output and this end it is V input. So voltage across inductor will be equal to V out minus V input. So here, how this boosting is happening? It is a step up converter and boosting is happening. That is, when the switch is in the open position, the total voltage coming in V out output voltage will be equal to this supply voltage plus inductor voltage. That is, V out will be equal to input voltage plus supply voltage. So it will be always more than input voltage. So we will derive the equation for V out. For that we can use voltage balancing theorem. That is V1 T on is equal to V2 T off. So here V1 is magnetizing voltage across inductor. That is when the switch is in the on condition, what was the voltage across inductor? And V2 means demagnetizing voltage across the inductor. That is, switch is in the off position. What was the voltage across inductor? So already we have seen that one. That is, V1 will be equal to magnetizing voltage means here you can see when the switch is in on condition, VL is V input. That is, VL is equal to V input. So V1 we can write it here as V input. So V input into T on is equal to, that is, V2 is demagnetizing voltage. So here demagnetizing voltage across inductor, that is equal to V out minus V in. So you can substitute it here. So V2 is equal to V out minus V input, that one, into T off. So just we will simplify this equation. V input into T on is equal to V out into T off minus V input into T off. Okay, we need the equation for V out. So I am transferring this V input into T off to right hand side. So V input into T on. Here it is minus. So when it is coming to right hand side, it will be, sorry, left hand side, it will be plus V input into T off. That is equal to V out into T off. So V input is common here. Please take it outside. That is V input into T on plus T off. That is equal to V out into T off. So already we know T on plus T off. That is total time period T. So T on plus T off is equal to T. So I am substituting V input into T is equal to V out into T off. And we need the equation for V out. T off can be taken to this side. That is V input into T divided by T off is equal to V out. So the equation for V out is V out equals V input into T divided by T off. So we need to transfer this equation in form of duty cycle. So we know duty cycle delta, that is equal to T on by T. So this equation needs to be in term of T on and T. So delta means that is duty cycle. So I'll be changing this T on and I'll be writing T on in terms of, sorry, T off in terms of T on and T. So we know T is equal to T on plus T off. So what is T off? T off will be equal to T minus T on. So we can substitute it here. V out is equal to V input into T divided by T minus T on. Now what we need to do? So T is there, T on is there. What we'll do means we'll be dividing numerator and denominator by T. So your V out is equal to V input into T divided by T by T by T minus T on by T. So here V out is equal to V input into T by T will be 1, and again T by T is 1, T on by T, that is duty cycle delta. So we have got the equation. V out is equal to V input into 1 divided by 1 minus delta. So thank you all.